Howdy ho! Great to have y'all around again. After about 2 months of unit testing and building components, we're actually going to run the application again. I suppose I didn't craft this tutorial in the most exciting way, but hopefully it's at least in a good way. Here's an overview of what we've been doing over the last couple tutorials and what we'll finish off today. As you can see, we've been working on these various layers denoted by the boxes of different colors. Last time, what we did was create a new pair from user method inside of the token service. In the previous lecture, or the one before that, we ended up creating a signup method in the user service and a create method in the repository, as well as creating a Postgres Docker container. What we'll do today is create a connection to this Postgres container and then inject that into the user repository, which will be injected into the user service, which will be injected into the handler layer. Furthermore, the new pair from user method, or actually the entire token service, will also be injected into the handler layer. With all of this injection set up, we are able to make API calls to the /signup endpoint and actually get users created inside of a database. We need to run our Postgres Docker container and then create a users table before we can do this whole dependency injection and insert users. Once we have this users table up and running with the proper columns, we'll be ready to establish that database connection that I previously mentioned. To be able to create this users table, we're going to use something called migrations. Migrations, in my rough definition, are snapshots of each change you want to make to your database. For each migration, we usually give a number or a timestamp and a short description of what the migration does. Each migration consists of 2 SQL files with SQL statements, one for updating the database, and another for reverting those updates. I ended up using a tool called Golang Migrate CLI to create and apply migrations. I'm just going to install this directly on my machine, though you can also install it as a Docker container. It was a little bit of a pain to copy over migration files to the container and then execute the database updates in the container, so I'm just going to stick with the local installation. You can install it however you prefer by going to this Golang Migrate repository, and then you should look for a link that will take you to the Migrate CLI, and as you can see, there are installations for installing the CLI on various operating systems or directly with the Go toolchain. After you've installed this CLI, you should be able to open a terminal, as I've opened here, and enter migrate -- version, and hopefully you have a somewhat recent version of the software installed. Since writing out commands with migrate can be a little difficult to remember, let's update our makefile with some commands for migrating tables to a database. I've opened up our makefile, which is in the project root directory, which is a sibling with the account folder. So at the very root, here is our makefile. I've added a few variables and commands to the makefile since last time. We have an mpath, which means migrations path, which just is inside of a migrations folder, inside of the account folder. I added the default port for Postgres 5432 and an N for the default number of migrations. You can change these variables when you run some of these commands if you need to. These 4 commands here are used for performing the migrations. What do? Migrate create creates a migration file in sequential order inside of the mpath folder. As we do not yet have this mpath folder or migrations folder, let's go inside of account and add a new folder called migrations. The next 3 commands are used for executing a discrete number of migrations as defined by this variable n. The default for n is 1, as we just showed. The migrate up command updates. The migrate down command reverts these updates. Migrate force can be used to force a version number, or in our case, a specific sequence number, which is often required if you have to fix an error in a previous migration. I'll admit I struggle with this and have to sort of hack or manually fix the database before I can force a specific version number using this command. The good news is that the migrate CLI has reasonably understandable warnings. To create the first migration, let's change directories up to the root. You can see I previously tried to run a make command inside of the account directory, so that's not going to work. So let's go to the project root, and then let's run make migrate create with a name that's a short description of what you want the migration to do. Excellent. Inside of our migrations folder, we have two files. Both of them are prefixed with this sequence number. I used 5 digits, the short description, and then an up or a down for making updates or reverting those updates to our database. Let's go to the .up file for writing the SQL statements to update our database. As you can see, this is just normal SQL, which I hope you are at least somewhat familiar with. The first line here adds an extension for creating UUIDs. When we create a user with email and password, UUIDs will automatically be generated. And that's what this statement does here, saying that we default to calling this UUID generate version 4, which is the random UUID. And this will be our primary key as well. All other columns are varchars, which instead of using null, will use an empty value or empty character string to represent no value instead of nil. Notice that we also have a not null varchar email column, and this must be unique as we do not want multiple users to be able to sign up with the same email address. Let's now add statements to revert these changes in our adduserstable.down.sql file here. This down file just drops the entire users table and then removes that extension for UUIDs that we installed. While this looks simple, you should make sure to drop the table first, as the UID column in the table depends on the UUID extension. So Postgres would interfere from deleting an extension if any table still exists which has a column requiring that extension. This is why we delete the table first, otherwise you will get an error. Next, we need to run a Postgres container or our Postgres container in Docker to apply these migrations. Before doing that, I want to make some changes in the naming of our docker compose.yaml file at the root of our project. So let's open up Docker Compose. And right now, inside of Docker Compose, we have this Postgres auth container, and I changed the name auth in this application to account to be more specific about what the container does. So let's change the service name to Postgres account. We also need to remember to change the volume to Postgres account. And then we have a main volumes down here. Lastly, let's make sure that this depends on statement in the account container now refers properly to Postgres account. So let's just save that. And that's all the changes I wanted to make just to fix some naming conventions. We can now go to our terminal and run docker compose up. And this time, let's just show that you can run a single container as long as it doesn't depend on other containers. Or maybe it will load those dependencies for you. Let's hit docker compose up Postgres-account. And it looks like I left some previous container up and running there. But so far it looks good that we are ready to establish a connection to this account container. With our database up and running, we can open up another terminal and make our migrations. So let's do that. I will open it inside of the root directory here. And all we need to do is run make migrate up, and it will know based on the sequence numbers of the file and some data in a table in our database which update to run. Excellent. So it looks like it ran successfully at our database and added users table. Excellent. I've decided to look at our tables inside of pgadmin, which is a free client for looking at Postgres databases. There's a lot of information here, but if you go under the databases, Postgres, which is the name of our database, and then schemas, we'll see two tables that have been created, users and schema migrations. Also, if you want to log in, usually you would just go to right-click this servers and click Create, but I hope you know how to use the client of your choice to look at tables, or even you might know how to use PSQL from the command line. Inside of pgadmin, I've executed a couple of statements. The first, I just want to select all of the users from the users table, just to look at the columns. So you see we have this UUID as the primary key, name, email, which should be unique, password, image, URL, and website. If you want to look at more details, you can right-click a table and look at the properties and the column details. And for example, you can also look at constraints and see that you have the user's key as the primary key. Aside from just opening the properties inside of the table, you can also open up the constraints and you can see that we have a user's primary key and a user's email key, which is that unique constraint that we added to the email. Aside from the users table, we can also query the schema migrations table. And you see that it gives us a version number related to that 00001 sequence number and a dirty state. The dirty state would just tell us if there was an error in a migration, and we'd have to go manually fix any errors in the database or update the errors in our SQL migration files, and then force a specific version number and then retry our migration. Let's go back to the terminal window and try running make migrate down just to make sure we can revert these changes. Now I'm back in pgadmin, and if we look at the schema migrations table, we should see there's no version number or no dirty. And if we even refresh this whole database here, we should see that we don't even have a users table anymore. So now that we know, at least in its basic form, that migrate works, let's reapply our migration. And now we have a users table that we're ready to work with. So I have some really good news. We are one step closer to actually running this dadgummed application. So we're going to take this Postgres container, we're going to establish a connection to it from within our main package, and then perform the dependency injection shown by this dependency flow arrow. The first thing I want to do is go back to that terminal running Docker. We have all the logs up, we're not running in detach mode, and let's just stop this, because we're going to need to run both our application and Postgres shortly. So we've stopped our Docker container. Let's go to the account application and add a new file called datasources.go. Now, the reason I'm creating this datasources.go is to keep our main file from becoming unwieldy and having a single place to initialize all of our data stores. We'll eventually create a connection to Google Cloud Client as well as Redis from within this file. Here's the code we've added to this file. Take note that we're going to import that SQLX library or SQL wrapper that we're using in the project. To be able to use this library to instantiate a connection to Postgres, though, you need to import the Golang Postgres library, which is just lib/pq, and we usually use an underscore to denote that this is just being used by another import. We're not actually using any methods or functions within this library directly, but we're doing it through the SQLX library. We'll create a data sources struct that's package private to only the main package. And right now it contains the database connection, but will later contain a Redis and Google Cloud storage connection. We then create an instantiator method called initDS, which either returns a reference to these data sources or an error. We'll read in a bunch of environment variables with connection information for our Postgres database. We'll add these environment variables shortly. With these environment variables, we create a formatted string with the host, port, user, password, database name, and SSL mode. And then we establish the connection with the sqlx.open method. If there are any errors, we'll return them. We also try to ping the database just to make sure we have a connection, and then we return this data sources struct. I also want to add a close method on the data sources, and this is just a nice method to add so that we can easily close all of our connections at the end of our main file when we shut down the application. So scrolling back up to the top, let's go ahead and set these environment variables. If you recall, we set our environment variables in a .env.dev file. Let's see if I can find that. Right now it is at the root of the project. And this file gets read in through Docker Compose. If we open Docker Compose again and go to the account application, you see that we list an M file. So any environment variable listed in that file will end up being injected into the container for access. I actually want to move this .env file into the account application because this file is only for our account application. So let's move it here. So as you can see, the .env.dev file is now inside of the account folder. And let's make that change as well to our Docker Compose file. So we can use a relative path, the account folder, and so now we have an M file scoped specifically to this container. Now let's actually add the environment variables for Postgres to the .env.dev file. I don't have a lot to say about these variables, but note that the PG host is actually the name of the Postgres account container because this environment variable will be read in from within the Docker environment. So we will not use localhost, we'll use the name of the container for networking purposes. All the other information are just defaults for a Postgres Docker container, and we previously set the password to just password. I also added some environment variables that we'll use with our token service for creating a refresh secret, and also our public and private key pair. In just a few minutes, we'll end up creating this new key pair and instantiating the token service. Now that we've created this datasources.go file in the main package, let's go back to the main file and call this init datasources function. We'll do this right at the top of the main file. And that is it. We should be getting an error because we're not yet using this data sources or DS variable. We'll fix that right now. And we will fix that by creating a new folder, actually a new file called injection.go. Also in the root of the account project. This file is also where we take that data source, inject it into the repository layer, inject the repository into the service layer, and inject services into the handler. Again, this is also in package.main. Make sure that you perform all of the necessary imports here. I've added some comments just to explain the injection I just said, and some logs. We create the user repository using the factory new user repository. We then instantiate a user service by injecting this user repository into it. Note that we're using these factory methods or functions that we've been creating throughout the course. Then there's a lot of code here just to load the RSA key files from a file. Do note that we're using the environment variables that we just created in .env.dev, and we check for errors. We use the JWT parse RSA key methods to get these keys. There's one for public and private keys, and these just store the private key as a specific type in the RSA package, and that would be RSA.privateKey. So we get a reference to that. Similar thing with the public key here. We load the file and then parse it as an actual RSA.publicKey reference. We read in that plain string refresh secret, and with those three things read in, we can instantiate our token service. Lastly, we're going to initialize the Gin engine with default settings and middleware using gin.default. And then we'll create the handler and pass in this router or Gin engine and the user service and token service. We then return it. Previously in the main.go file, we instantiated the router and the handler here. Now, instead of doing that, we're just going to call our injection function. We do that like so. We say router or error and assign the inject function, and we pass in the data sources. So now that error goes away for the data sources. We check for an error and panic, if so, and then we pass the router into our generic or regular old Golang HTTP server. We still have all of our shutdown code here. Let's make sure that we also shut down our database connection inside of this code here at the bottom of our main file. We'll add this code directly below where we create the context and defer its cancellation. And let's save and get the indentation right. So we just run ds.close, that's the method on the data sources, and check for any errors. Now we need to do one more little thing before we can proceed, and that is to create a new key pair with the ._dev extension to it, or suffix. If you recall, inside of our env.dev file, we're now using RSA keys that have this _dev. Let's create those now. We'll do this by using our make helper command here. And you should now see we have two sets of key pairs. I guess that's redundant, a set of key pair, but here they are, and we have a public and private dev key now. It's now the moment we've all been waiting for, actually sending a request to this dadgum application. Let's run it by making sure we're in the root directory, which we are here, and running docker compose up. Let's cross our fingers and hope this works. We could test this API with curl or write a sequence of requests. To test it out, I'm going to just open up Postman. I've created a post URL here and added the base, which is malcorp.test. We set this up very early on in the application when we set up traffic. So go back to the first tutorial really if you want to see how to set up this URL to your site. And then we'll go to the extension API, accounts, and sign up. If we go to the body tab here in Postman, I'm going to send the JSON body with an email and password like so. And the password is valid password 123. Let's send this. And you see that we get a token pair back. It looks like it may just be working. If we reopen pgadmin, let's run the select star from users query here. I had a little warning there because I had shut down the connection to this database and then reestablished it. As we can see, we have this email address, guy01, and their salted password with the period in the middle there somewhere here, just as we planned. So that looks pretty good. If we open up Postman again and try to send a request to sign up another user called guy01, let's hope we get an error. And we do, we get that status 409 conflict, just as our application planned, with a message saying that the email with guy01@guy.com already exists. Excellent. Let's now sign up another user because I want to see what those tokens look like in a JSON debugger. Great, user 2 is signed up. Let's copy this token from the ID token. And let's go to the jwt.io website and paste this into the debugger. I've now pasted in this token. And you can see that we have a user ID with the proper email and an expiration. Let's see. Yes, that expiration is about 15 minutes from now. Perfect. If we look at the IAT, that is the creation time. That's 9:10. And then let's go up. And it's 9:25 for the expiration. Let's also paste the refresh token and verify its secret. You can see we have the option to enter the public and private key here to verify the signature. That's kind of a pain. I'll just do it with the refresh secret. Here's the body of the refresh token. Note that the header this time is HS256 instead of RSA256. I failed to point that out earlier, but just go back in the video. Let's paste that secret from our environment variable. Let's clear out this secret that goes here and let's paste it. And we see that our signature is now verified, and we had a little warning here saying it was not a good secret. What a surprise. Well, folks, that's it for today. Not gonna lie, these last 3 tutorials were kind of a B. For any of you that have even watched a segment here or there, thanks so much. That makes doing this all the more worthwhile. I have some topics lined up for the next 3 tutorials. Next time we'll do some cleanup. Further down the road, we'll create a token repository for storing refresh tokens in Redis. We'll also create that Redis container in Docker. After that, we'll create a handler timeout middleware. While Golang's HTTP server has some nice settings for read and write timeouts, between the server and client, we want to create a timeout for the handlers themselves. While Golang's HTTP server has some nice settings for read and write timeouts between server and client, we want to create a timeout for the handlers themselves. Golang actually has this feature as well, but it's not directly compatible with Gin. As always, les agradezco. Ciao.